Mixtures of 3. So in the last lesson, we learned how to solve 3 by 3 systems of equations, which is a nice skill to have. Somebody gives you 3 equations, 3 unknowns, you can solve it. That's nice. But what's really nice is when you can set up your own systems and use them to analyze various situations that you're interested in. So we're going to look at 4 examples in this lesson. You might think back 2 lessons ago when we were doing mixtures of 2. We had 5 different kinds of word problem that we looked at in that lesson. Here I'm going to introduce 2 more kinds, and then the other 2 are going to feel familiar perhaps. But anyway, 4 examples. This will help get the juices flowing. Mixing nickels, dimes, and quarters. That's a little different. We're mixing coins together. Biff has a bunch of money in his, quote, silver jar, which means nickels, dimes, quarters. He knows he has 114 coins altogether. How does he know that? I'm guessing it has one of those special coin jars where you put the coin in and it actually keeps count. He has 1 more quarter than dimes. Okay, some kind of a clue there. And how many of each kind of coin does he have? There we go. Doesn't this sound a little bit familiar? I mean, when we were mixing coffees, we had different kinds of coffee. We had how much of each, and then we had, how much are we spending on each? Here we have different kinds of coins. We're counting how many of each, and we're counting how much money they're worth. So it's kind of similar in some sense. It'll look a little different, but as before, it makes sense to sort of get a table going. Say, what have we got here? Well, we got nickels. What else we got here? Well, we got dimes. What else we got here? Well, we got quarters. And think in terms of the collection altogether. So maybe I'll just put total. Nickels, dimes, and quarters. Okay. Now, as with the coffees or the nuts or whatever, we're going to keep track of how many pounds, or not really how many pounds, how many coins, how many, and then how much do they cost, or not really how much do they cost, but what's their value in dollars. How many nickels and how much are they worth? How many dimes and how much are they worth? How many quarters and how much are they worth? Okay, so I like to, as you know, I like to go back up here. I've got my table sort of filled in or set up. Now I like to come up here and say, what are they telling me directly? They're telling me it adds up to $10.15 altogether. So the value of the whole collection is $10.15. I will put that right there. Cool. So that's getting us started. They telling us anything else? He knows he has 114 coins altogether. How many altogether is 114 coins? Okay, well they're telling us that pretty directly, I suppose. And are they telling us anything else? Well, they're telling us here that he has 1 more quarter than dimes. Okay, if you don't mind, I'm going to save that for later. And then the question, how many of each kind of coin does he have? Now, why am I saving that for later? Because we're expecting 3 equations, 3 unknowns. And if you look at your table, it's got 3 rows in it. So the unknowns, I think you can just kind of go like that, right? So how many nickels? I don't know. Let's call it X. How many dimes? I don't know. Let's call it Y. How many quarters? I don't know. Let's call it Z. Notice you're not using X for all of them. You're not using X here and X here and X here. You could if you somehow knew that the number of nickels equals the number of dimes equals the number of quarters. In other words, you had the same number of each, but we don't know that. We don't know that at all. And so if X is the number of nickels and the number of dimes is different, we got to use a different letter. The number of quarters is different again, so I use another different letter. So an X and a Y and a Z. Beautiful. Now, you can say something like this as well. Remember, we used to go across the table and say, let's think about each row. Nickels, I got this many nickels. So how much are they going to be worth? Well, each nickel's 5 cents. If you want to work with cents, you'd say 5x. That's how much the nickels are worth. Except we're going to work with dollars instead here. So keep your units consistent, right? If I'm working with dollars, then instead of 5x, I should write 0.05x. Anyway, similarly for the dimes, they're worth 10 cents each, or I should say $0.10 each. Quarters are 25 cents, which is $0.25 each. Now we've crossed the table going that way. We've got the table completely filled in. Now you try to take a different kind of look at things. How can I look at this differently? And the answer is, well, you can look at it in a column sense. What is this column saying? It's saying the number of nickels, the number of dimes, the number of quarters is 114 total. Those three things, X, Y, and Z, have to add up to 114. Beautiful. We got an equation right there. I'm going to call that equation number 1 and hang on to it. Similarly, it's this much money worth of nickels, or this many dollars worth of dimes, this many dollars worth of quarters, and they have to add up to 1015. So that's another equation. So 0.05x plus 0.10z, or excuse me, plus 0.10y plus 0.25z is equal to $10.15. I'll call that my equation 2. Cool. Let me pause for a little bit here and make a note. P.S. Make sure each term in an equation, and I mean any equation, any kind of word problem especially, you want to make sure you're paying attention to units. Each term in any equation should have the same units. Why am I saying this? Because one of the most common mistakes I'll see is I'll see somebody write an equation. They're saying, I need an equation. What can I do? What can I do? I'll do this. Can you see why that's a bad equation? That's a very bad equation. It doesn't work. Now what they're thinking is, I got dimes, I got nickels, I got dimes, I got quarters, and all together it's $10.15, and that's how you do all together is you add. So, but there's a problem here, and it's because this over here is a dollar amount, and these are not dollar amounts. These are just counting how many coins you got. If you got 2 nickels, 2 dimes, and 2 quarters, that's not $6. That's 6 coins. See what I'm saying? So it's like you got to make sure the units are the same. So like here, this is counting coins, counting coins, counting coins, counting coins. It's all the same. This is when you multiply the number of nickels by 0.05, you're converting to dollars, right? You're figuring out how many dollars that's worth. This is dollars, this is dollars, this is dollars. Make sure the units are the same all the way across. Point made. So let's see. It's probably a good idea to leave that note there, but I would like to shrink it. It's kind of getting in my way. So I'm going to kind of go like this. Boink. Okay, cool. Now we get to another point that we need to make, and that is, hey, you can't solve for 3 unknowns, x, y, and z, with only 2 equations. The reason we have 3 by 3 systems is if you want to solve for 3 different things, you'll need 3 different equations, or with what I'd like to say 3 clues. You need 3 equations, i.e. 3 clues. So notice we kind of had 1 clue right here when they said 1015 altogether. That was 1 clue. We got 1 equation out of it. This was another clue, 114 coins altogether. So we got another equation out of that, basically. But we're going to need a 3rd clue, and so we have to come back to this part that we saved. So let's get some of this stuff cleaned up. Okay, so coming back to the part that we saved. It says 1 more quarter than dimes. Okay, come back down to here. 1 more quarter than dimes. Well, here's another part where you need to be careful. If you're going too quickly, you've only got a 50-50 chance of getting this right. How do I say 50-50 chance? Because, well, pretty much everybody knows that one more is going to mean add 1 to something, right? That's what 1 more is going to mean. But the question is, do you want to say dimes is quarters plus 1, or do you want to say quarters is dimes plus 1? you want to stop and think about it and make sure you're choosing the right one before you do the rest of the problem and then change your mind later. That would be a bummer, right? So which one of these is correct? How can you convince yourself that one or the other is correct and the other one's wrong? Well, here's a little trick I use. I just look at what this is saying and I say, do I have more quarters or do I have more dimes? One more quarter, I have more quarters. Quarters should be bigger. You can write it this way. Quarters should be bigger than the dimes. Which of these equations is the Q going to be bigger than the D? It has to be this equation. Because here's the D, and then you add 1. Get it? That gets bigger. And so the Q will be bigger than the D. So it has to be this equation here. Okay, so that's just a cute little trick you can do to make sure that you, that you pick the right equation, I guess. So having picked the right equation, I suppose we should get back to X, Y's, and Z's, right? So Q was the quarters, that was the Z. And dimes was the Y. Okay, so here's our actual equation 3 right there. Cool. And so now you see we have 1, 2, 3 equations, 3 unknowns. We can solve this as a system. Now, how am I going to solve this as a system? Well, this third equation that we just built, this one's kind of begging for substitution, don't you think? Begs for subbing. Remember when we were playing with 2x2s, we said if one equation says x equals or maybe y equals, then it's kind of begging you to substitute. Well, this says z equals. That's begging me to substitute as well. So where should I do this? I guess I'll do this over here. So put 3 into equation 1, and what do we get? We get x plus y plus, and then where I see the z, I'm substituting this stuff, which is y plus 1. Oops. Which is y plus 1. Okay, so that equals 114. So if I simplify this equation, it's saying x plus 2y basically, and then you subtract 1 from both sides, you get a 113. I'm calling that my equation 4. Now I'm going to plug 3 into the other equation, into the second equation. What's that going to say? So I'm looking over here at the second equation. 0.05x plus 0.10y plus 0.25 times the z, and the z, I'm making this substitution here. The z is a y plus 1, equals, what's that say, 1015. Okay, simplifying this equation, 0.05x plus, well, let's see, I'll have a 0.1y plus this, so that's going to be a 0.35y. And then I'm going to have to subtract 0.25 on both sides, so this is going to become a 990. And so that becomes my equation 5. Okay, cool. Now I just need room to solve this stuff. Let me try to shrink this down again. I'm going to take all of this. Yep, try to shrink this down a bit. There we go. Okay, cool. Hey, what are you doing? It's resisting. You shouldn't do that. What? Let go. Okay, cool. It worked. Now let's solve this little 2x2 system. Let me go to a different color. So I'm looking at this equation and I'm looking at this equation. I want to solve by addition, I'm thinking. I think what I'll do is, see how I got a 0.05 and here I got a 1? I could turn a 0.05 into a 1 by multiplying by 20, right? Because 20 nickels is $1. And actually, let's multiply by -20. So equation 4 becomes x plus 2y equals 113. This one, -20 times 0.05x is going to be a -x. -20 times this is going to be a -7y. And -20 times this is going to be a -198, I think. Come on, I was doing this before. What'd I get? Yeah, 198. There we go. Cool. Now I can add these two equations together. And what do I get? The x's go poof. So I've got a -5y here. This is a -85. And then you divide both sides by -5. And you end up real quick like with 17 for your y. And as long as you've got that, might as well come back up to this equation. and solve for x. So x plus 2 times y is 17 equals 113. So x is 113, take away 34. Let's see, 113 take away 4 is 109, take away 30 is 79. And then, you know what, I might as well just come right up here to equation 3. Put y equals 17 into equation 3, that one, because it says z is basically equal to y plus 1. So z is equal to 18. Cool. Now, let's go back up to our table. X is 79. What was X? X was how many nickels? We got 79 nickels. Y was dimes. We got 17 dimes. And then this was 18 quarters. And if you want to check yourself real quick, you can grab out a calculator and go you go 79 times 0.05. That's how much the nickels are worth. Plus $1.70 for the dimes. Plus 18 quarters is going to be $4.50. And that adds up to, lo and behold, $10.15. It's all working. Pretty cool, huh? That was a good word problem. I like that one. Let's do another word problem. Let's do investments. We've seen investments before, except maybe not 3 in a row, or 3 kinds of investment. This is Theodore Theodorefson. They call him Ted. He's got $100,000 in his retirement account. Okay, cool. He needs to specify an allocation between 3 investment classes. Safe, 2%. Moderately risky, 4%. Aggressive, 10%. Okay, I've read enough to know that we need to set up a table. So before I go back to reading that, let's get up a table. Let's see now here. We've got basically the safe in class, which they describe as a 2% return, right? They have a moderate class, which they describe as a 4% return, and they have an aggressive class, which they describe as a 10% return. Cool. And then, of course, you're going to have your total overall, whatever you want to call it. Cool. Now you want to keep track of how much you're putting in and how much you're getting out, right? So there's the deposit into each, and then there's the return on each. Okay, cool. Now let's go back up and start reading. $100,000 total. His total retirement account, $100,000. So we know where that goes. Cool. Needs to specify an allocation. Safe is 2%. Got it. Moderately 4%. Got it. Aggressive 10% over the long haul. Got it. By the way, that's basically what they say about stocks. The stock market is 10%, but of course it goes up and down and up and down. So if you've got 80 years to work with, you might want to invest in the stock market. Anyway, that's all that information is taken care of. After much deliberation, he decides he's going to balance risk with reward by aiming for... So you could put it all in the stock market and say, hey, I'm going to get 10%. Or you could say, well, let's not take that much of a risk. I do want to retire fairly soon. He says, I want to have a 5% overall. So where does that 5% go? I guess it would go here, right? And that's all that they're telling us. So now we can start doing the old fill in the table trick. So that's what they told us directly, the blue stuff. Now we put in our green stuff. Well, 5% of 100,000 is 5,000. So he's hoping to get a $5,000 return at the end of a year or whatever it is. Okay. So how much is he depositing in each of these? Well, there's 3 things we're solving for. Might as well use the XYZ, right? You assume he's depositing different amounts in these 3 accounts, so you have to use 3 different letters. So you use an X, Y, and a Z. And then you can go across like this. Well, the return is going to be 2% of this, so the return from that account is 0.02x. The return from this account is 0.04y, and the return from this account is 0.10z. And as you can see, we've already got our table filled in, and as a bonus, we've got 3 equations we can write already, because all of these deposit amounts have to add up to $100,000, and all of these returns have to add up to $5,000. Here we go. X plus Y plus Z is equal to $100,000. Cool. 0.02x plus 0.04y plus 0.10z adds up to $5,000. Cool. That's my equation 1. That's my equation 2. We're stuck because we did use all the information they told us, we got our two equations. That's what that information tells us, right? Their first clue was, hey, depositing this much. We got an equation out of that. Their second equation was, hey, 5% total return. We got an equation out of that. But I wanted to make the point again, if you're going to solve for three things, you're going to need three clues. We need a third clue. So if they don't give you a third clue, then you can't solve it. I suppose you could go back to Ted and say, hey, we need another clue. What else? And by the way, that's why I put this PS here. So I kind of wanted to draw this point out once more, that three equations needs three unknowns. And by the way, looking to the future, you got 5 unknowns, you need 5 equations, 5 clues. You got 20 unknowns, you need 20 equations, 20 clues. 1,000 unknowns, you need 1,000 clues, and so on. So, what are we going to do here? Well, Ted says, you know what I think I'll do is, I think I'd like to, maybe, actually, I'm going to think about this a little bit more here. Let's see. Let's make sure that we put twice as much in the safe as in the, we'll say the moderately risky. That's a Ted decision. I want to make sure that there's twice as much in the safe class as there is in the moderately risky class. Okay, now we got to build an equation out of that. So come down here. What does this mean? Twice as much in the safe as the moderate. Stop and write an equation. Now again, be careful on this step, because you basically, if you're going too fast, it's just a 50-50. Twice as much in safe as moderate. Does this mean that the moderate is 2 times the safe? Or does this mean the safe is 2 times the moderate? Those are the only two things I'll see people write. They'll write one or the other. But which one is right? Which one's correct? So again, I'm going to say, remember that clue. You can sort of look at this and ask yourself, well, which has more, the safe or the moderate? Twice as much in the safe makes it sound like the safe account has more money in it. The safe has more money in it. Which one of these two equations makes it look like the safe number is bigger than the moderate number? It has to be this one. Because you're going to take whatever the moderate number is, and then you're going to double it to get a really big number, which is going to be how much is in the safe. The safe is more than the moderate over there. Okay, so it's a really handy-dandy thing you can do to make sure you use the right equation. It's this one. And now let's go back to x, y's, and z's. The safe is the x 2 times, and then the moderate was the y. So this becomes our third equation. We got 3 equations. Boom, boom, boom. We can start to solve. Once more, this one's kind of begging me to do substitution method. X is 2y, huh? Well, let me put that in here. You're saying that this x is just a 2y? Cool. Plus y plus z equals 100,000. And then you're saying that this x is just 2y? Okay, 0.02 times 2y plus 0.04y plus 0.10z is equal to 5,000. Okay, so those are going to become my 2 equations, but let me put them over here. So the 2y plus the y makes a 3y plus z is equal to 100,000. And then here, this is a 0.04y plus another 0.04y, so it's a 0.08y plus a 0.10z is equal to a 5,000. And I will call that my official equations 4 and 5. Right. Okay. Now we got to solve these together. How about we take the z's and make those go away? I can multiply this by a negative 0.1. That seems like a good idea. So then I'd have a negative 0.3y minus a 0.1z equals a negative 10,000. And then if I add these 2 equations together, 0.08 minus 0.3. Now be careful with your decimal places here. That's going to be a negative 0.22y. The z's are going away, of course, and that's a negative 5,000. And so if you divide both sides by the negative 0.22, you're going to get a positive, and let me see what I get. 25,000 divided by 0.22. Boom. 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 I'm getting $22,727.27, right? 22,727.27. Yep. There's Y. Now I can get X right away. Let me change, well, let me go back to green. I can get X right away from this equation because it says X is equal to 2 times Y, 2 times the 22,727.27. So X is equal to, well, let's see, 27 times 2 is a 54. That's a 54. That's a 14, 2, 4, 5, 4. How's that look? So X is 45,454 or so. Okay. And then if you want to get Z, I know how to get Z. You get Z by saying, hey, they all add up to 100,000. So Z is equal to, you take 100,000, you subtract that, and when I did that before, I got a 31,818.18. Cool. That's how you should distribute or allocate your investments. Now let me put a big PS up here. Rounding etiquette, not etiquette. Wisdom, rounding, hygiene. Rounding hygiene. If they ask you to round to nearest dollar, what does that mean? First, work with cents. Round last. Last. Why does this make a difference? Well, if you were to round this now, this is 22,727. If you were to round this now, it would be 45,455, right? Because the 50 cents rounds this up. Okay. Life is good. Life is happy, right? But notice that if you had rounded this and then plugged that in here, you would not get this. You would get 45,454. And you might say, oh, who cares about $1? But you want to know how to round properly, because sometimes it's the precision of various instrumentation, whatever. Sometimes it is important to get the rounding right. So that's what I'm trying to say here. And this is a general fact of life. Whenever it says round your answer to however many decimal places, okay, you wait until the very end to do that rounding. If it says round to 2 decimal places, I'm carrying lots and lots of decimal places while I'm in the middle of the problem working on it. It's only when I get to the very end that I'm going to round off. Okay? Point made, I hope. Point made, I hope. Round at the very end. Not in the middle, but at the very end. Okay, that's 2 down, 2 to go. Can we get you to move a little bit here? Let's see if we can move some of this stuff. I'm not going to be able to move this stuff. Yes, I am. I'm going to move this stuff. No, I'm not. I'm going to move this stuff right here. Let's just shrink that down a little so it's not quite as in the way. Oh, why does it do that? I have to learn. Why does it do that? Why does it do... What the hell? What? One more time. Okay, now, what are you doing? I'm trying to pinch. Okay. There. Whew. Man, touchy little thing. Anyway, here's our third example. This one's a little different than what we've been doing. Might not look different because what do we got? We got donuts, cookies, scones. We got counting how many. We got money. It's all kind of the same quantities that we're playing with again. Well, it's the same quantities. Let's try making the same kind of table thing. So we got donuts. We got donuts. We got cookies. We got cookies. And we got scones. Okay, cool. Okay, cool. Okay, cool. And then we're going to count, well, I guess I'll put total down here. We're going to count how many of each. That's supposed to be a how many. How many. And then, of course, what's their cost or value, or however you want to say that. So, let's start filling this in. I'm looking at this first sentence. It says if I buy 8 donuts and 12 cookies and 5 scones, that will cost me, that goes over here, $17.95. Okay, that's what that's telling me. Now notice I'm going to have a hard time entering this in the same table because that's like, well, now I got 7. Okay, so let's ignore that for now. Let's just look at what we've got here. What can I do with this table? I can fill it in the rest of the way, I suppose. 8 plus 12 is, okay, I got 25. That's something. Now, how do I get the cost here? I would have to take the price of the donut and multiply it by 8 because I'm buying 8 of them. So how am I going to do that if I don't know the price of the donut? Well, guess what? That's the question. So in this case, it's the cost of the donut is what we're solving for, and the cost of the cookie and the cost of the scones. So I usually put that information over here, X dollars each, Y dollars each, Z dollars each, but it shows up in the middle of our table here because 8 donuts at X dollars each is going to cost you 8X dollars. 12 cookies at Y dollars each is going to cost you 12Y dollars. 5 scones at Z dollars each is going to cost you 5Z dollars. So looking at the equation, looking at the table in the vertical direction, well, this doesn't tell me much. 8 plus 12 plus 5 is 25. I kind of knew that. But this gives me a nice equation. This gives me a really nice equation. So let's write that equation down. I got 8x plus 12y plus 5z equals $17.95. And in fact, I don't think I want to write it there. I think I'll slide it on over. Okay, cool. So I got this one equation by looking at that one table. Where am I going to get the other equations? Well, I'm going to get them from over here. I don't think I need to set up equations here because you kind of see the pattern, right? I mean, it's like, look what you got here. You got 8 donuts, 8x, 12 cookies, 12y, 5 scones, 5z. Total cost $17.95. It's kind of the same pattern all the way down here. So I got, looking at my second clue, 7 times the cost of a donut plus 6 times the cost of a cookie plus 9 times the cost of a scone is going to add up to $17.40. And then looking at the third line, 12 donuts, 12 times the cost of a donut, 18 times the cost of a cookie, 6 times the cost of a scone is equal to $25.50. That was actually kind of fun making those 3 equations. Okay, there's my 3 equations. 3 unknowns. Okay, this one's going to be a little more intense to solve. That's okay. This will give us good practice solving by extracting a 2x2 is what we say. So I'm taking a quick look at these 3 equations. I'm saying, do I feel like getting rid of x's, y's, or z's? I kind of like the y column because I can multiply 6 times 2 to get 12, and I can multiply 6 times 3 to get 18. So my plan is to get rid of y's. So let's do something like this. I'm going to multiply -2 times equation 2 and add equation 1. That'll make this a -12y, which will cancel the positive 12y. That's my plan. So what is that going to look like? Well, -2 times this row is going to be a -14x minus a 12y minus an 18z equals a -$34.80. And then I just put equation 1 right underneath it as is. 8x plus 12y plus 5z is equal to $17.95. And then when I add these 2 equations together, -6x, the y's go poof. -13z is equal to negative, what the heck is that? I want to say 1685. Yeah, 1685. Cool, let's call that equation 4. Now, over here, let's combine a different pair of equations. Now let's work with the 6 and the 18. So I'm going to multiply equation 2 by a -3. times equation 2 and add equation 3 to it. So negative 2 times equation, or excuse me, negative 3 times equation 2, that's going to be a negative 21x minus an 18y minus a 27z is equal to negative, what, 5220? Put equation 3 underneath it as is. 12x plus 18y plus 6z is equal to 2550. And now I add those two equations together. I got a negative 9x. The y's are going poof. Negative 21z equals negative 2670. Okay, and I'll call that equation 5. So equation 4 and equation 5. Cool beans. Now, let's do something like, let's see, I want to combine these two equations. Let's change colors here to help keep track of myself. I'd like to make the x's go away. The common denominator there would be an 18. So maybe I'll do like negative 3 times this equation 4, and then I'll add 2 times the equation 5 to it, because I'm going to multiply this by 2 to make a negative 18, this by negative 3 to make a positive 18. This should work. So what have I got here? So if I try to get rid of some of this clutter, okay, negative 3 times equation 4. Negative 3 times negative 6 is a 18x. Negative 3 times this, 39z. Negative 3 times this goes positive, 48, 49, what the heck is that going to be? Times 3, 48, 49, 50, 40, 50, 55. I hope. Okay, and then this equation times 2. So it'll be a negative 18x, negative 42z, and 2 times that is a negative 5340. So if I add these two equations together, the x's go poof. I get a negative 3z, and here I got a negative something. 285. Yeah. Dividing both sides by negative 3 will get me a 0.95. So that's the price of a something. The scones, I believe. So the scones are 95 cents each. Cool. Now I can take that equation, or that answer, really. I can take a new color. Let's plug that into any one of these equations will work. Let's plug this into equation 4. And that's going to give me that. A negative 6x minus a 13 times a 0.95 is equal to a negative 1685. Negative 6x. All right, what's 13 times 0.95? 13 times 0.95 equals. That is a negative 1235 equals a negative 1685. So a negative 6x equals, you add the 1235 to both sides, you get a negative 450. And so x is equal to a positive 0.75. Oh, cool. So the, what is it, the donuts that come first? They're 75 cents. Now you want to get y. Well, you just need an equation from almost anywhere. One that has x, y, and z in it. Let's go with this color. So now I'm going to finish by plug x and z into equation, which one do you like? I'm going to plug them into equation 1. So it's 8 times x, x is 0.75, plus, looking at equation 1 up here, 12 times y, plus 5 times z, z is 0.95. Those have to add up to 1795. 8 times 75 is a 6, plus a 12y, 5 times 95 is a 475, I believe, equals a 1795, so 12y is going to be 1795 minus 1075. It's going to be 720. And so y is going to come out to 0.60. So now we've got our three prices. These are in dollars. So the x's are 75 cents. What's that? That's the donuts. 75 cents. The Y's are the cookies, and those are 60 cents each. And the scones, those were the 95-cent things, right? Yep. Pretty cool. Pretty cool. Okay, for our fourth and final example, we're going to look at curve fitting again. Last time we took a look at if you had 2 points, you could put a line to it. You could do it the old-fashioned way, get your slope formula out and so on. Or you could just set up 2 equations to unknowns. Same thing with a parabola. Drop the microphone on the floor. That's the first thing you should do. And then when you get the microphone picked back up, okay. So with a parabola, you'll need 3 points because parabolas are a little more complicated. They're more complicated because, as we'll see in a later lesson for sure, you can write the equation of a parabola this way. Some number times an x squared plus some number times an x plus some number. Notice straight lines are like mx plus b's. Well, parabolas, you have this one extra term, which is a squared term. So that's pretty cool. Now, actually, what I'd like to do is I'd like to turn this equation around, write it the other way. ax squared plus bx plus c equals y. That's the formula I'll use. So I've got 3 unknowns, really. I need to know what's the a, what's the b, and what's the c. If I know what those numbers are, I've got the equation of a parabola. Y equals blah x squared plus blah x plus blah. Cool. So 3 unknowns. Where am I going to get 3 equations? Well, I need 3 clues. Here's 3 clues. I got 3 points. So the point 0, 0. Let's use that one first. I'm plugging in x equals 0. That's the first thing I'm doing. So plug a 0 in there and square it. Plug a 0 in there. And that's supposed to give me y equals 0. Boink. Now this equation is nice because 0 squared is 0. 0 times b is 0. This equation tells you right away, oh, c is equal to 0. That's nice. If you ever have the point 0, 0 on your parabola, that's going to happen, and it's going to be nice. Not saying it's always going to happen, but if it does, it's nice. We should go in hunting for more equations here. Now let's use this point. The point 2 comma 4. So when you use x equals 2, so I'm putting it up here, right? A times a 2 squared plus b times a 2 plus c. Oh, wait a minute. C is 0. Might as well use that right now. Equals the y is supposed to come out to 4. Cool. So this equation is going to be 2 squared is 4. 4a plus 2b plus 0 equals 4. I'm going to call that my equation 1. Notice that really we're going to end up with a system of 2 equations, 2 unknowns. Man, is it nice when it goes through the origin. Anyway, our third point is negative 2, 6. This is where we get our third equation. Our first equation being this very nice one. So I plug in x equals negative 2. So a times a negative 2 squared plus b times a negative 2 plus c is 0. Might as well use that. Equals y, which is supposed to be 6. So if you simplify this equation, negative 2 squared is a 4a minus 2b equals 6. And that becomes my second equation. So like I say, it's theoretically it's 3 equations, 3 unknowns, but you'll get lucky if it goes through the origin. It'll shrink to a 2 by 2. Gee, I think we can just add these equations right now because I got a plus 2b and a minus 2b. That's gold. That's gold. So adding those 2 equations together, 8a, the b's go poof, equals 10. And so a is equal to 10 over 8. Please reduce your fractions. A is equal to 5/4. Bada boom, bada bing, bada bing, bing, boom. Plug that into equation 1 to get b. So 4 times the a is 5/4, plus 2b, or not 2b, no kidding, equals 4. Okay, so remember how you multiply a whole number to its fraction. This is like 4 over 1. Remember that thing also about how you can, when multiplying, you're allowed to do this cross-canceling stuff. Only when multiplying, but we're multiplying, so we're allowed to do that cross-canceling stuff. So 1 times 5 is a 5 over 1, which is meaningless. So 5 plus 2b equals 4. So 2b equals negative 1. B equals negative 1/2. And so now we can write our final answer. Let's write it in a snazzy purple color. So that means y equals ax squared plus bx plus c. We know what a is. It's 5/4. We know what b is. It's -1/2. And we know what c is. It's 0. There she blows. So I'm not saying you'll get that lucky on the homework. On the homework, I'll bet you anything, you probably won't have the 0.00, but that's okay. You just get a 3x3 system, just like this one. You get a 3x3 system, just extract a 2x2, and you'll be there in no time. You'll have your nice answer.